to the user. So we'll have a look at some of these errors today and see how we can do something more useful than what we've done in the past, which is maybe just show a print statement or a fatal error message that just crashes the app. So that's kind of our our plan. And as usual, if you have any questions about anything that I'm talking about, please yell out and throw your hand up, or just turn on your microphone and discuss it. And we're happy to address those questions.
Yeah. One thing I'll sort of add to that is for the remaining labs that you're going to be sort of seeing over the next few weeks, some of them may be short, some of them may be long, but in a lot of them, there's also just some useful tips and tricks and things to be aware of, even if you might not necessarily be using that particular framework. So it might just be worth having a quick glance at some of the labs, even if you don't end up doing them, just to sort of see if there's any information in there that might help you in your final application.
Right, exactly. They might have particular useful patterns, or they might do something that we haven't seen before, like I'm discussing with the handling errors thing that is sort of incidental and not directly part of one of our learning outcomes, but is nevertheless something important that you may use for your apps.
Yeah, as like another example, we're going to do a messaging one in the following weeks, the week 8 lab. There may be some cool information on like how to structure your Firebase thing, even if you aren't doing messaging. It might give you a better context on how you could do that.
Yeah, for sure. All right, so what are we working towards with this app? So let me open the lab exercise. All right. So, sorry, my simulator's on the other window screen. Where is it? It's right here. All right. No, that's the wrong simulator. Okay, so I wanted to actually show this app on a couple of different devices. Let me just show you first on the simulator we've been using, which is the iPhone 16 Pro, for many of the demos. So this is the app. It's a little 3-view controller app. One of them is a map view. You can see as well, it's in a navigation controller, and it's a bit hard to see, but there's because there's no, the navigation bar here is transparent, which is the standard behavior, which is something we can also have a look at how we can address today. If you tap on this, it goes back to another view controller. And if we tap on either of these entries for Monash Uni, we get an annotation, which is basically a pin that's shown on the map. These are called annotations. And it jumps the view to that particular point. So the map is centered on that one. And that's a bit strange that it didn't display the actual map data. I don't know why it didn't load, some weird connectivity thing. Now, it also has a third view controller here, which is a little one where we can add additional locations. And you can see it says, use your location while using the app, and gives a little button where we can enter a latitude and longitude and some information, and it saves it and puts it into the list. And here's one of the things to notice. You'll see this says Cupertino. This is obviously in the US. The simulator doesn't, my laptop here doesn't have a GPS sensor in it. So it's not using any actual physical location of the device. It's simulating locations. And if you, in the simulator, under the features menu, there's a locations option. And there's a few of these. There's a custom location where you can physically enter a location to set a longitude and latitude and a place. But you can also um, see some different modes of moving location. A city run, obviously, where someone's just running the streets, a bicycle ride, and a freeway drive, and then a static location, which is just Apple's campus. So these are some locations you can use. There's also in that little overrides menu that we've used before to set dark mode when you for your running app. There's a dozen different locations of major cities around the world, like Berlin in Germany, Hong Kong, China, Mumbai, India, this kind of thing. So you can also set the location from there, and that's used by the simulator. Um, so that's pretty much what the app looks like. Again, no persistence, just those three screens. But one of the things that, if we go and have a look at the storyboard for this app, you can see that it's got this sort of strange structure. Let me just here's our locations list and the new location. They're inside a navigation controller. So that's sort of structure we've seen many times before. Then you've got the map view also inside a navigation controller. And then both of these two navigation controllers are inside a split view controller. And we mentioned a split view controller before, but we never actually saw its behavior. And this is a nice view controller that on an iPhone will behave just like a single navigation controller. But on other devices with more space, and this could be an iPhone Pro Max, or it could be an iPad, or it could be an app running on macOS, an iOS app running on macOS, it shows as a multi-pane layout. So you have both views displayed at the same time. So it has a primary and a secondary view. And each of these two navigation controllers we see here are the primary and secondary view. But if there isn't enough space and you're on a small screen device, what's called a small size class, then they get collapsed and they just look like a single navigation controller to us. So, I mean, that's what we're seeing here. All three of these view controllers, the location list, the new location, and our map view controller, appear to us here to be just part of a single navigation controller stack. Here's my new view controller. I can go back, I can tap on this and get to the map view controller. But here's where it gets interesting. When we start running this app on devices with a different size class, like an iPhone 16 Pro Max, so that's a device that has a larger screen. Looks the same, when we open it. Here it is. I've got the simulator scaled, so it's slightly smaller even. But when we turn this device sideways, it has this behavior. The split view controller has this behavior where it overlays the location list over the map. And it automatically adds a little control here. And I can tap the control, reveal the location list, jump to a point. Right? So this is a slightly larger size class. If I turn it back to portrait mode, it goes back to the previous behavior we saw. Now, I can run this on an iPhone, no, not an iPhone, an iPad Pro 11-inch. So this one, an M4 iPad. So I'm just going to reopen this simulator. Yeah. So, dun, dun, dun. Okay, so here's it launching. Here in portrait orientation on the iPad, and this is the 11-inch. There's an even bigger iPad, I think, a 12-inch one. Is this a smaller one? I'm not sure now. Hold on, I'll have a quick look. Yeah, there's a 13-inch iPad and there's 11-inch iPad. So this is the smaller of the two iPads that are available at the moment. And in portrait mode, it has the same behavior as the iPhone Pro Max did in landscape, where it displays this location list as a little kind of popover over the top of my map, and I can just hit this button to reveal it. But then if I turn this one into landscape, it has a different behavior again, which is it now says, oh, there's enough space that I want this view to be permanently displayed. And if I hit the plus button, we see that new location view controller displayed here. If I click back, I end up back here. If I tap on either of these, it's not hiding the location list. It's just always available. And again, I do still have the control where I can choose to hide or show that pane. So there's quite a lot of flexibility here. Some of this is controlled by properties of the split view controller. So you can say, I want this pane to always be displayed for a certain size class. So we could have made it so that on the iPhone Pro Max in landscape mode, it always showed this particular pane or view controller here, or we can have it with the behavior it has where it sort of slides over and displays. So, as well as this being a sort of simple maps example with annotations, it's also showing you how you can make use of a split view controller. Any questions about that, either from people here or online?
No major questions yet.
No, that's fine.
There is a, well, hang on, here we go. Do we need to build the lab for the iPad?
No. So when this app, so the Lab 7 or supplementary, week 7 supplementary that I'm showing here, you just write it as an iOS app. I mean, the steps take you through construction of the split view controller, but you don't do anything special. By default, pretty much all of the projects we've created so far, and it's a good question, have this under the targets thing under our project settings. We have this area here which is says supported destinations, and by default these apps are built for iPhone, iPad, Mac, and Apple Vision. But the Mac version and the Apple Vision version are just displaying an iPad app in that environment. And usually when we run these, like you could take pretty much any of the lab classes we've done up until this point, and you can just select an iPad as a simulator. If you didn't already, you'll find them in the simulator list and you run it on there. And usually what happens is it just looks like a big iPhone app because everything is stretched. And as long as you're using constraints, your views adjust. And it just means that, we could take our movie app and it would just be a really wide list. Once you start using a split view controller, it adapts better to the size and understands it. But you don't have to do anything special. I mean, to that point, that was a good question that was asked. Here we have a Mac app, and I can select the Mac as my destination. You may not be able to do this, I'm not sure. It may require like you to be signed into a developer account to run the iPad app on your Mac. But as long as I've got a team set up in here, this should work. Just give me a second. I'll see if I can run this. So if I select, my Mac as a destination, so it gives an error. And it gives an error because it says it requires you to enter a team. Because I'm signed into an Apple developer account, I can enter my team and I should be able to run this iPad app on the Mac. And what that looks like is this. It's just bouncing. So, here we have a Mac app. It's got menus just like any other Mac app. But you can clearly see it behaves like an iPad app, and it looks like an iPad app. Sort of looks like a weird hybrid between a Mac app and an iPad app. And some things you can do, you can dynamically resize the window, and if we had views that were laid out with constraints, you'd see them adjusting their size as that happens. And the behavior is pretty much the same. You will notice some weirdness, like the permissions for accessing location are different on the Mac. So we didn't see the prompt asking us for permissions, and we don't see the button displayed here. So there are some things we might have to sort of debug and check if we're running on Mac. There's some slight differences. But oh, and I should say this is something that you can do like for any iOS app that you release on the App Store. There's just a little checkbox, and it basically says, are you happy for this to be available to Mac users? And if so, then if someone downloads or buys your app and they have a Mac, they can run that iPhone app directly on Mac. And this is partly enabled because the newer Mac laptops use the same Apple Silicon processors that are in the phones, which means they, run the same code, and they've just made sure the frameworks work on here. Now, I mean, one further point as well to that question that was asked of, do you need to do anything special in terms of targets? It is possible, and this is something I wanted to show either this week or next week anyway. We can remove this Mac target and add a new one. And when we choose Mac targets, it has a couple options here. It's got the Mac and it says use AppKit and SwiftUI to access the full capabilities of the Mac SDK. That's basically a native Mac app, an app that uses AppKit, which is different than UIKit. They're sort of like somewhat analogous frameworks, but the view controller part of them is different. They use the same underlying core location and things like that, but the individual view controller classes are different. Then there's design for iPad, which is what we just saw. It just says run your unmodified iOS app on a Mac with Apple Silicon. So the caveat that is there, it only works on an Apple Silicon Mac. And then there's this third option, which is what's called Mac Catalyst. And we can add this target to any of our projects. And what it does, it says enable Mac Catalyst for those who may not be able to read the small text here that I can't make any larger. It says for Mac Catalyst builds, this target and its dependencies will link or embed only Mac compatible content. So it's sort of a warning saying, be aware that some parts of your iOS app might not work on Mac, and that locations permissions thing is an example of it. And it says the source code will be unaffected and may still require changes. So yeah, we agree to that. We create this target, and what it now does is it tries to be clever about taking your iOS app, but modifying the way controls are displayed to make them more Mac-like. And there's an entire whole Mac Catalyst tutorial online you could work through, and it basically says, here's an existing iOS app. Here are the steps we would use to convert it. So while this is not something we cover directly in the unit, there are various ways that if we've written a UIKit based app, we can also display it and run it on the Mac. And I can show you what this one looks like. So now I've added this target, I could select the Mac Catalyst version as a target for my app. And it will still run as a Mac app. It'll show in the dock. It'll have its own window. I can move it and resize it and all this sort of stuff. But you'll see it looks different, right? It already looks a bit more Mac-like rather than an iPad app that's displayed. It'll utilize, having said that, it still looks quite iPad-like anyway. But you can still see some simple things like integration of this navigation bar into the window. And there are, some pretty quick changes that you can make to the app that start to make it more Mac-like. So these sidebars often have a level of transparency or a different color, like the one we see in Xcode. So you can with not too many changes, start addressing those and making it fit into being a much more Mac-like app. Yeah, so that's a good question. Anything else? No. So we will, what will we do? Oh, maybe I could show, can I show an alert controller here? I mean, what I could do actually is if I just find in here, authorize, there's a couple of places where we use this authorization when in use. Is it authorize always? Yeah. So this authorize when in use is an iOS thing, and the Mac version needs this authorized always, and we should request authorized request always authorization. Okay, so if we make those three changes and rerun it as a Mac Catalyst app, it should at least allow us to get the user's location. Yeah, and okay, because I've compiled this app before, I guess it already has the permissions. Can I turn that off? Maybe. Location. Give me a second. Let me see if I can turn off the when I use the simulators, I always reset them so they'll like ask for permission, so you'll see it. For location services, what's this app called? Lab 7. All right, here we go. I think I can turn this off and you'll see the sort of initial behavior if you've never run the app before. Oh, I can't do it. There doesn't seem to be a way on Mac to delete a previous app that had been run. I guess I could change its. I don't want to spend too long on this, but I mean, I can do it in the simulator, but I was trying to show you where like you get automatic differences for things like an alert view controller that we've seen before. And because the permissions are shown in an alert view controller, you'll notice it looks like a Mac alert now instead of an iOS alert that's just shown in a Mac window. But actually, a better way to demonstrate this will be we'll do some work later with like action sheets and context menus. I might actually make those changes to this Catalyst app in a future workshop, and then we'll be able to see how like it adapts to use Mac style things for context menus or other common controls, let's say. Okay, so look, that's the lab solution for the week 7 supplementary. Go and have a look at it. Explore a bit with how split view controllers work. So like even if you're planning an iOS app, but in some time in the future, you plan to potentially make it available also as an iPad app, because you can release apps that work on both iPad and iPhone together, then this could be something that you might want to utilize, just so that you make it easier later with your app design. Um, all right, so I put up this, and what we're going to do now is we're going to go through some questions related to the pre-workshop material and also just some other things related to location use. So we saw in that lab demo, um, about getting location information, so getting the user's current location and saving that to, yes? What? What am I doing, really?
1 second. Might be the wrong link.
Is it the wrong week? Hang on, maybe I've got the wrong slide deck. Is this week 7? Yeah, this is week 7. It looks, is it the link is wrong or the QR code is
Yeah,
wrong?
it's taking us to week 5.
What? Okay. Thought I checked this yesterday, but give me a second.
I
Oh yeah,
can
what the heck?
publish a link in chat.
Is it this? Is a QR code right?
That should go to week 6 for those that are in chat.
Hang on. No, QR code is wrong too. What have I done? I might have put like updated it in the wrong slide deck or something weird. Give me 2 secs. Some kind of user error. Sorry, folks. Okay, well, Jason's put the link into the chat. So you're probably all good. For people in the room, give me a second. Uh, person, I'll update it here. Right. Week 7, where are you here? Week 6. Don't know what I've done there. And we will do published, copy. Just check your link still works, Jason, because I don't know if the shortening thing. Okay, and all right. We will be back in business now, maybe. All right, let's try this one. Is this good? Okay. Sorry about that. Don't know what happened there, folks. Any case, the for the quiz questions, I'm going to ask you about this discussion that we're going to go through now. And I'm also going to ask you about the live coding like usual. One of the things that's different for the quiz from this week onwards, I want you to tell me something that isn't in the pre-workshop videos, okay? So I don't want you to just say, Michael showed how to put an annotation on a map, because the annotation on the map stuff is covered in the pre-workshop videos. So I want you to tell me something you learned that's actually come from this activity. And that will be the case going forwards as well. And yeah, so let's start here and get back on track. The first thing I wanted to ask is just about general capabilities of core location, which is the set of frameworks we're using here. And we saw how we can get the user's location, and we can also track their location as it moves. What else can core location do for us? I talked about some other things in the pre-workshop videos. What else can we do via core location? Thoughts? There's another obvious one that I talked about that's subject of one of those videos. Someone online? I'll just hang out for a while you think about it.
Geofencing.
Yeah, and what is geofencing?
Another person said current location / geofencing.
Current location. So current location is yeah, something we already talked about. Absolutely does current location.
Continuously monitor the device's location as it moves.
Right. So this is what geofencing does for us. Thank you. It basically says I'm interested in an area, and this is why you can get things like targeted notifications for a flight when you get to the airport, or if you've made an appointment at an Apple store, when you get near to that Apple store, you'll get information from that because it's monitoring the device's location and then doing that and then giving like the device, waking up the device if you like, or giving the app a notification when it gets to a certain point, and you can run some code. So and there's a benefit to geolocation, and the benefit of geolocation is that it's efficient, right? Because you can certainly have an app run in the background and have it monitor the GPS, but you will drain the battery life very, very quickly. Like, think about how many of you have used GPS navigation on your phone, and think how quickly it drains the battery. It's one of the fastest ways you can probably drain the battery on a mobile device like a smartphone.
It's typically why you plug your phone in when you're driving, GPS running. It's
Yes, and if you forget to do that or you need to do navigation in someone else's car, you quickly discover how much that's necessary. So absolutely true. And I mean, the benefit of the geolocation stuff is it's monitoring coarse grained. So it uses some clever things that we'll talk about in a bit. And it monitors major changes in location. And then once it knows that it's nearer to what it's monitoring, it can do more fine-grained monitoring. So the operating system can be smart about these locations.
There is some comments that have been put into chat that I actually really like.
Yeah.
So one student has said that it defines a geographic boundary, circular regions, which is probably pretty important to be aware of. It's actually usually a circular part of a map. But it can trigger events on entering and exiting this region, sending a notification, that they've arrived at a location, or, for example, Hoyt Cinemas prompting your account card when you're near one of their cinemas.
Yeah, perfect examples. And other ones are like reminders app. You can ask your personal assistant, whose name I won't speak in case my devices trigger off them. But you say, when I leave home, I want this to happen, or remind me to do something when I get home or get to work. And it's the same thing. That's how these features are supported. So yeah, this is one of the things we talked about. What's one core location concern or limitation that we've discussed? One of them is obviously battery life. We just talked about that. But what's something else?
Accuracy.
Accuracy, yeah. Accuracy is something we need to keep in mind. And if you look at the way the APIs work, various features of them require you to specify accuracy. You need to say, oh, when I'm monitoring location updates, I care about them from a human walking perspective or a driving perspective. If you're driving, there's less need to do fine grained things. Or you can say, I care about them at kilometer distance. So I really only care to know really what suburb I'm in or something like that, rather than exactly where I am within 10 meters. Because the accuracy of GPS, if you've got an accurate lock and no cloud cover and things like that, is about 10 meters.
Another one that we've had is permissions.
Permissions, great. So that's another one. That's sort of often the most obvious one that people talk about. Yeah, you're potentially accessing the user's location. And if you could just do this without any permission from the user, then you could have any app you download, could be running in the background, could be monitoring your location, could be sending that to anywhere. And it was certainly the case in the early days of the App Store that many apps, especially social media apps and other ones that could sell this information, would do lots of tracking of the user's location. And as a result, both Android and iOS ask for permissions for this. Um, and that's why we saw those permission prompts. And you can also go and revoke those permissions. And it's considered private information. And for what it's worth, if your app asks for this, you need to specify it in the app's information. So there's an info plist file where you put this information. But if you submit it to the App Store, you also need to specify that information there. So there's like little badges that appear on the App Store that are sort of like the health food badges we have on food products in the supermarket that talk to you about the privacy details of the app. And location's one of the things that is you have to list there if it's something that your app collects, and you need to say why you collect it.
Yeah. So a comment's been that we have to specify what the location will be used for and things like that.
Right. And exactly. So good point. That's something like when we um, specify that information, it actually dictates what's shown in that message that's displayed to the user when asking for permission. And that's something that is reviewed as part of the app being reviewed. So yes, you not only need to say, oh, my app uses location, but it should be telling the user, why is it asking for that? Why does it need it? So they can make a smart decision about whether or not they allow it. And as I said in the videos, like um, your app should behave nicely if it doesn't get permission. I mean, it's fine for it to say, oh, I need access to this to provide this feature, and therefore it doesn't work without that feature. But it should show the user some information that says that. It shouldn't just crash, or there's some part of the app that doesn't work. So the thing I had before in that Lab 7 example, you can still enter a location manually, but if they've provided permission, there's an extra button that pre-populates those fields. So it still makes the app useful, doesn't stop it from working, but yeah, you respect the user's wishes.
Yeah. So there's another one here, which I think is really good. So geofencing limitations. So as an example, iOS allows monitoring up to 20 regions per app, and the regions must be relatively large, at least 100 plus meters. Fine-grained geofencing is not practical.
Yeah. And I mean, okay, so you can probably, yes, that's absolutely true. And from what we've just talked about, you can probably understand why geofencing works the way it does. It says fine grain geofencing is not practical. Why would you not want fine grain geofencing? Because of battery limitations, right? Like in order to do fine grain monitoring, you need to poll the GPS for this accurate location. Whereas the higher level location, you can only turn on the GPS periodically, or you may be able to even get that information from other sources. So, I mean, this is actually a good segue into something that I like to talk about here.
I'll quickly jump in with one more thing that someone's mentioned.
Yeah, sure.
So they've sort of said that a lot of apps don't let you proceed if you don't provide those kind of permissions. With one other one said, which definitely feels more like an ethics issue.
They
But
don't let you what, sorry?
proceed.
I'll proceed. Yeah, yeah.
And this is something where it will depend upon what you as the developer feel like the user should be allowed or have access to if they allow those permissions or don't allow them. Some apps will turn around and say you're not allowed to use certain things because if you don't give us your location, then a lot of the features of this app will not work, and therefore we won't let you proceed into the application. Whereas, if you do provide it, then, these features will work and you can go further in. It comes down to what you as a developer, I think, feel is important. Yeah,
Yeah,
in your
and I
decision.
think sometimes this is done out of spite. They're like, okay, if you don't give us access to all this private information, you get nothing of the app. And if you have a look at Apple's app review guidelines, so these are different than the human interface guidelines, and there's something we'll talk about in week 11 or 12, and there's sort of the rules for you releasing apps on the App Store. There's some advice there that says, you shouldn't. Um, I don't know what the right word is. It's like paywalling, but not exactly. You shouldn't lock features of your app behind prompts for information or things like this. So, like as an example, they say someone shouldn't have to enter an account in order to like create and enter an account in order to do something useful with the app. They should be able to use the app, and then if there are features that require an account, well, you allow them to enter an account to sort of access those features. And look, this is not something that your app would typically get rejected for. Like they wouldn't say, okay, we're not releasing it onto the store, but it is best practice. And I kind of feel the same way as what Jason was just saying. For me, the best way to write an app would be still allow the user to use everything they can. But if there's things that require their location, you just allow those by them providing that permission. And they can choose to do that as you saw on the screen. They can do it once, or they can always allow it, and they can revoke it. And yeah, and you don't have to sort of stop them from accessing the rest of things. And incidentally, this is one of the things that you know you might someone might say to you, why would you need to monitor authorization? One of the things you'll see in my lab, no, my workshop demo later in this workshop is I'll set up this delegate method and it will listen for authorization changes. And you might say, well, why do you need to do that if you've got the permission at launch or whatever? But while the app is running, someone can just jump across to settings and they can disable the app's access to the GPS. They can turn off the location access, which is basically like going back and undoing that alert that they approved. So your app needs to not only check it when it launches, but monitor for changes to this authorization. So that's also something to be aware of. One of the things I like to discuss here is how exactly GPS works, right? Like you folks have, I assume, all used a device with GPS. And like, let's say at the end of your day, you need to go somewhere that you haven't been before. So you go to navigate there, and that might be via public transport, or it might be via driving in a car. How quickly does the device know your current location? What do people think? Is it instantaneous? Is it 5 seconds, 10 seconds, 1 minute? Is it always the same? Is it different? What are your experiences?
One saying different, 2 to 3 seconds. Um,
Does it ever get it wrong? Is it always correct? Is it initially wrong sometimes? Does it improve over time? What sort of behavior have you seen?
If someone was stationary, it might be inaccurate, especially with direction, but after moving, it improves.
Yeah. So there's a range of things that you realize may be happening, and you can kind of see that from the behavior. So, I mean, my experience, and I would assume is the same experience that many of you have had, is it can sometimes be very quick, as in like it knows exactly where you are and it's accurate. Someone's noted it's sometimes if you're stationary, it's wrong. And then when you start moving, it starts getting more accurate. I've certainly seen this driving out of the campus. You know, it thinks I'm on a different road. I drive for a little bit and it flips over and it realizes where I am. And if I'd stayed in the same spot, it would take longer to figure that out. Um, Anything else that people added?
Another one good thing to sort of add. One person's obviously pulling up the documentation or chat GPT, which is great. It's actually
Oh,
providing some good information. It says that it refines to a precise GPS within about 5 to 20 seconds. But in saying that, another student has actually said that they usually keep their location off. So it usually takes them about 5 seconds for it to be accurate. So that's sort of giving you a bit of evidence of that's what's occurring. It is that 5 seconds or so to get that information.
yeah. Um, Look, it will really vary. And if you are just using GPS, it can vary based on having, how GPS works, right? Um, is there's a bunch of satellites in geosynchronous orbit. I can't remember how many of them. Each one sends out a repeating signal. That repeating signal takes almost a minute, I think, to repeat. And what your app is doing when you use GPS, it doesn't use Wi-Fi. You can use GPS even if you're in the middle of the desert and find out where you are on the planet. You can use the compass app. You might not be able to load a map to see what the terrain around you looks like if you don't have an internet connection, but you'll be able to figure out where you are. And what it does is it has a radio, and it's a radio that just receives, it just listens, and it's listening to those signals from the satellites. And it needs multiple because it's triangulating a location based on which satellite signals it can hear. And it can take quite a long time. It could take even up to a minute if there was no other information available to it, right? So if your app just had the GPS, and nothing else, it didn't know where it was immediately or initially, it can take quite a long time to get an accurate location. Now, this is not the behavior we see, right? That's not been our experience. We certainly see inaccuracies and we see it get better over time and we see it gets better with movement. So you might be able to start to think about or guess some of the ways that our devices figure out their location because, maybe surprisingly, it isn't just GPS. So, what else can a device use to know its location?
Yeah. I'll sort of add to well, there's another, that's a good answer. Someone said motion there.
Yeah, so yeah,
So,
that's, I mean, before you go, Jason, that's an obvious one because we just talked about it, right? If you know, as you start to move, the devices can track their location in space. They have accelerometers and gyroscopes in them. So they can use that information to refine it. So yes, they're using motion information and
Wi-Fi signals.
Wi-Fi signals. This is an interesting one. So I was going to say look around us, but it's only useful for the person here sitting in the room with me. Most of you are online, but for the one student in the room and Jason and I, we can look around the ceiling. There's like 4 or 6 Wi-Fi. There's 6 Wi-Fi access points in here. They're these white boxes. Don't know if they see on the video, but
8.
oh, there's 8.
Yeah.
So there's 8 Cisco Wi-Fi access points in this room, right? If you're in your own house, many of you are probably on Wi-Fi, and you have an access point too. All of those access points have a unique ID. And even if you can't connect to them, so like a stranger is in your house or outside your house, and they can see the Wi-Fi network. Even if they can't access it, they don't know the password, they can see the ID, which is a unique identifier for that access point. They don't have a location per se, but Google and Apple and other smartphone software providers maintain databases of Wi-Fi access points and locations. So let's say I didn't know where this lecture theatre was, and I had GPS turned on, and I walked to the lecture theatre, and my phone says, "Oh, I know your GPS location, and I can see these 8 Wi-Fi access points." It goes, "I'm going to update Apple's database or Google's database with a GPS location for each of these access point IDs." So then some other student is here, they don't have GPS turned on, and they see this access point, and it can do a little web lookup if they've got an internet connection, and it can say, "Oh, that access point is known to be at that GPS location." But it could be wrong. And sometimes you see this. Sometimes the initial location provided by your phone is not in the right place, right? So they use some of this information quickly at first because the GPS is slow, and it's expensive in terms of battery use. Doing a little web request with an access point ID or 10 access point IDs, if you've got them, is real quick. It doesn't require much battery life. Your phone's using the internet all the time to access things. So yeah, you can use this information. Anything else that you could potentially use for figuring out your location?
Well, one thing I'll sort of mention
Oh,
there.
hang on.
Oh,
Sorry,
yeah.
go. Bluetooth. Yeah, Bluetooth is another great one. So, some things like shopping centers and airports actually have Bluetooth beacons that are fixed Bluetooth broadcasters, let's say, and they say this is my location and this is exactly where I am, and you can via Bluetooth understand the proximity of your device. Our Bluetooth chips in our phones over the last few years are smart enough that if there's a Bluetooth beacon on the other side of the room, I could know that I'm 10 meters away from it. And as I walk towards it, my phone will be able to send a signal to it, and check the response time of bouncing the signal off that beacon, and it will know I'm now 5 meters from it or 2 meters from it. So Bluetooth is something that can be used. Sorry, Jason, I cut you off.
No, that's all good. One student here has sort of mentioned a scenario earlier on, which I want maybe to have people think about.
Yeah.
So they're sort of saying that they find that in like enclosed areas and things like that, the location might not be as accurate. For example, if they go into a shopping center, it all of a sudden it'll be close, but it might not be as accurate.
Yeah. So this is a really good point. I mentioned the cloud cover thing, but I didn't mention it with GPS. But GPS needs access to the sky to see the satellites. It doesn't work inside. It doesn't work in a tunnel. Like even if you drive through one of the tunnels in Melbourne, you'll find, or you less so now, but in the past you could have found that it would drift and it would track you and think you're in a different location and then sort of jump to the right point when you left the tunnel. Um, as we get more and more indoor locations with things like Bluetooth beacons that provide this information, you get more accuracy, but it can be the case in many indoor locations that GPS doesn't work correctly. It's why I don't do GPS demos in class, actually, because
Yeah,
things don't work well in many of the lecture theatres.
yeah, 100%. But that might sort of also allude to the idea that maybe the phone might be able to remember the last known location and things like that as well.
Yeah. So when I mention these lookups of things, I am sure, I don't know it to be true, but I'm sure that the phone also remembers locations of common Wi-Fi networks that it connects to, like your home one, work ones, things like this. And because then if it can check it locally and it doesn't need to do a web request, then it doesn't need that internet connectivity, and it's faster. So I'm sure it caches much of this information too, but if it's just an unknown one it sees when you've just got off a plane somewhere and turned your phone and your internet connection on, then that's when it can do these lookups.
Yeah, I always find it fun when like my phone tells me, okay, it's time to go home when I jump in the car to leave or something like that, and knows exactly where I'm going to be going. Um, Other students have said cellular networks and things like that.
Yeah, cellular networks. And the fact you're saying cellular networks and not like mobile phone networks suggests this might be something that's been suggested from a website or a kind of chat GPT response, but it's nevertheless correct. And the idea is this won't work on an iPad, but it will work on a device that has a cellular radio, a mobile phone radio in it. And how that works is your phone has that internet connectivity because it's connected to mobile phone towers. You know, these big things you see on top of buildings with the large vertical kind of bars. And it does the same thing that it can do with the satellites. It does triangulation, and you can find where a device is based on which towers it was connecting to and the signal strength or signal round trip speed to. I'm not sure exactly how it's done for the mobile phone towers. But yes, it's another way. And again, it's not as accurate as GPS. You're not going to get like 10-meter accuracy, but it's fast, right? So it's another thing that can be used. So, like many of these sensor-based things that we use or radio-based things we use on iOS, you'll find there's a fusion of different things that are done that's smart behind the hood. You ask for a location, and it may be the GPS gives you it. It may be that something else gives you it. But you just get a location and you don't really know all of the details of this. So, our discussion here is sort of talking about how this works because sometimes it explains behavior we see, and it also explains why you don't just ask for the location initially because it might be inaccurate. And, this is why a location on iOS will have an accuracy value. And at first, that accuracy value, and you would have seen it in the Maps app, might be 50 meters or even 100 meters. It'll be a big blue circle. And then over the course of 20 seconds or whatever, it reduces down until it's centered on you and it's maybe 10-meter accuracy. And that's it giving you some certainty of how it's calculated this and what the accuracy is and how sure you can be.
Yeah. Another student has asked, does apps like Apple Maps use information cached from other users to help triangulate your position? Not, yeah, I mean, like to a degree, but a big thing to sort of think about is if you've ever used, navigation apps and you might be, see like traffic and all that kind of stuff that is available to you. A great way, yeah, to sort of do that is seeing how traffic is building up in an area because there's a lot of cellular devices that are slowing down or not moving as fast when they were moving fast. And it can actually work out, why areas are sort of building up in traffic because there's a lot of users in that area that are slowing down. And yeah, so they can use some of this information. Yeah, it's cached.
I mean, yeah. So as Jason said, you absolutely can do this, and I think they use official traffic information in some places, and you can find that when we have a look at the sort of credits in iOS for the Maps app, you'll see they use lots and lots of data sources. Um, but yes, you can use that information, and particular apps like Waze, the app Waze is completely crowdsourced traffic information. And what they do is, yeah, they just use all the different users to understand the movement of traffic. And Apple and Google do this too. And you know, some of you might have read there was an artist a few years ago on who got like, I don't know what it was, 200 or 300 smartphones and put them in a little cart and walked across a bridge in the US and showed how in the Maps app he managed to make it, a big red line with a traffic jam, even though the traffic was moving, fine across there.
Perfectly fine, but him in his shopping cart with 200 phones.
Yeah, exactly. So there are, this is sort of a way that you could practically demonstrate what's going on here. And I mean, back to this question, do you use other people's devices and locations to figure this out? The answer is yes, because like you might look at something like some of you may have AirPods, maybe. If you've got AirPods, you can locate them. And they don't have a GPS receiver in them. I don't think they have Wi-Fi either. They just have Bluetooth radios. So the question is, how do you locate them? And the answer is you locate them through a kind of mesh network of Bluetooth devices. And This is also how AirTags work. If some of you have heard of or used AirTags or Square, no, not Square. Who's the Tile? There was a company at Tile that made little Bluetooth trackers, and they're just like a tiny little thing with a little battery in them, and all they've got is a Bluetooth radio. But you can use them to locate something. And you ask yourself, well, how do you do that? How do you figure out the location for that? And the answer is you figure it out based on people who have smartphones, which have GPS or can figure out their location and have Bluetooth radios, being able to connect to these and understand based on this Bluetooth round tripping the signal time to talk to them. This happened to me like on the weekend. I was like, oh, where did I wasn't this weekend, it was last weekend. I was mowing the lawns and doing some garden work, and I'm like, where have my iPods gone? And I looked around for them, couldn't find them anywhere, walked back, backtracked them. Um, in the end, I resorted to the like searching for it with Find My, and I'm wandering around the house and I couldn't find a signal anywhere. I went out and I'm like, oh, I put something in the bin. Did I put them in the bin? So I went close to the bin and the signal was low. And I walked to the like middle of my lawn where I'd been mowing and it said hi. And that's weird. And so I wandered around a bit more and I got a fish pond in my garden. And next to the fish pond, there was a little flower pot that I'd moved that was on the lawn. And it was really strong there. And I bent down, and underneath the leaves in this flower pot were my AirPods. And I'm like, oh man, how would I have ever found these? And it turned out as I bent down to pick them up, I was wearing an old pair of jeans that had a kind of tear in the pocket, and they just fallen out into the flower pot. So this is how you can locate something like these trackers, because they talk via Bluetooth, and it doesn't need to be your phone. So this is the nice thing about like the Air tags is, I might have lost something. It works with, say, people's luggage in airports, or like maybe you put it on a bike and the bike gets stolen, or something like this. And they, in a privacy safe way, they use the location of other people's devices to be able to share the location of nearby things. And the really nice thing is Apple and Google have actually worked together on this. So there's a sort of like open standard where they've worked on the privacy issues, and it's both Android and iOS devices that understand the locations of these trackers and work together to share the location. For the user that owns it. Anything else people wanted to add or ask?
No, I think it's most of it so far.
Hmm. So there you go. There's a sort of deep dive into the way location stuff works. But I find this really kind of fascinating because it's clever technology and it works well and it does make your life easier. And it saved my AirPods from getting lost. So that's a good thing.
Student said it's great until it dies and you only know the last location 12 hours ago.
That is absolutely true. One of the interesting things, that's for sure frustrating. One of the interesting things is Bluetooth, especially the newer versions, what called like Bluetooth Low Energy. These things are really efficient, and this is how you can have an AirTag. I don't know if anyone's got AirTags. I don't actually have any of them, but if someone online has one, maybe you can talk about and just say how long the batteries last on these things, because it's actually insane. And yeah, for sure, if you lose a phone or something,
About 6 months.
6 months, yeah, right. So with a phone, it could be annoying if you run out of battery, but at least the iPhones now, if they run out of battery, they're still findable because they save some energy, like much less than is needed for the GPS or the screen or anything else, but just to keep it broadcasting and locating, and also so that you can use things like not sure if it's credit cards, but like access cards for doorways. So like at Monash, I use my phone as my method of entering doorways and stuff. So it can also work even if the phones run out of battery. So I think as the technology and the uses of it keep improving, also some of the design decisions around the device improve as well. Devices improve as well. Yeah. Okay, so maybe at this point, this is a good time to jump into the live coding stuff. I'm going to show you some uses of MapKit and MK map view, which is MapKit map view. And yeah, talk you through some of the stuff related to errors and asynchronous code. So for the start of this, I'm just going to create a brand new app. So I'm just going to say new project, a new iOS app. We'll call it Workshop 7. And to start out, I've got a blank view controller here and a blank storyboard. And I'm just going to get a map view. So we just say map kit, map view, drop it onto here. And I'm going to constrain it to the view. And I'm just going to say 0, 0, 0, and 0, and add constraints. And we're going to run it. But not on a iPhone Pro 16. Yeah, let's do that one. All right. And as per usual, if you want to ask any questions as we're doing this, just yell out and do so. I'm going to try and make this slightly smaller so that it... let me just close it and reopen it. It'll resize. I think the resize handles are annoyingly on the bottom. I'm not sure they're on the top. Okay, here we go. All right, so here's my app in just a moment when it installs. Okay, so doing that one step, putting a map view on, gives us all of the interactivity of a normal map. So in the simulator, if you hold down the Alt key, you get these little resize handles. They're centered around the beginning, and they rotate around the center of the screen. And as I move my mouse and start either at the corners of the screen or the middle, I can use this to sort of pinch out to zoom out, or pinch towards the center to zoom in. I can also use it to rotate the map. You can always, this map is set by default, I guess, to re-rotate to be north, or maybe that's just because I'm zoomed right out. Let's see if I zoom in. I can rotate this round. Yeah, at some point, maybe it's only if I zoom right in. So you can tap and pan and zoom. Yeah, okay. So when you zoom right in, you can rotate so it's no longer north facing. But if you tap the little dial at the top, it'll rotate back to be north facing. Interestingly, and this is where maybe I want to be. I'll show you when we set it to a particular location. Oh, we could go look at Adelaide, I guess. Let's go look at Adelaide. One of the things you can also do here is if you hold down Shift and Option, you actually get this ability to tilt the view. And if you zoom right in, you actually see 3D buildings. So, you can basically see here, and it takes a bit of skill to get used to the controls. I would like to say I have great ability to mimic all of the touch controls in the simulator. But there you go. You get a sense of the default map, which is this one. If you zoom in and hold down this Option and Shift and basically tilt it, you start to see 3D buildings. And these are done from satellite images. So like if you're out in the country on weird land, buildings will sometimes be odd shaped and trees might be different heights and things. But for cities, they're usually pretty good to give you a rough indication. All of that was just the MapKit view. You might notice it's annoyingly got buffers at the side of the screen on the left and right from where this dynamic island is and where the little handle at the bottom is. So that's annoying. This is because our constraints are set to be based on margins. How you could fix this is if I go into the size inspector and select my MapKit view, or if you created these constraints, you could uncheck the box that says constrained to margins. But here you'll notice, and it might be a bit hard to see online, but it says the first item is attached to the safe areas trailing value. I can click on this and on the drop down and go into the menu and change it to the super view. So if I do this for each of them, anywhere it said safe area, I'm just going to change it to super view. So safe area here for all 4 of these constraints. And the last one, it said safe area, I'm changing it to super view. Now, a couple of these you'll notice for this constraint, for example, even though I've changed it to the super view, it's set it to a constant value of 118, which is the distance it already was from the top. So I'm just going to change that constant to 0. And now the map view will be constrained right to the boundary of the view, which is maybe what you'd expect for something like a map where you're okay seeing it extend right to the edges of the view on the device. So then it looks a bit like this. All right, so now let's actually interact with this. Let's interact with this map. So to do this, the first thing I need to do is in my view controller, just create an outlet to this. So we're going to say map view, create an outlet so I can connect to the map view. Immediately, it's going to complain about this. Map view, as the sort of initials or prefix on the beginning suggest, it's part of a different framework called MapKit. So we need to import MapKit. So that's us importing MapKit. Now we'll be happy with that. There are certain things that we like to respond to, and we do this by becoming a delegate, by our view controller becoming a delegate of the map view. And that means when the user clicks on an annotation or the user hands the map, you can respond to it. You can jump in and do something in response. So let's do that. MK map view delegate. Yep. The other part of becoming a delegate is, like we've seen many times before, we would now say map view dot delegate equals self, right? That's us actually saying that our view controller is the delegate. And then it turns out that all of these delegate methods are optional. So here's the documentation for them. Map view delegate, you can respond to map position changes. You can know when the map has loaded things. You can track the user's location. You can manage annotations, like there's a sorry, selecting annotations. So there's a like map view did select annotation view. So if the user taps on a pin, you can know that they tapped on it and you can respond to it in the same way you could with a table view controller. So these are some of the things you can do. Don't have to do any of them. So we'll just not do anything with that. So maybe the first thing I'll do is let's just set a location on the map would be the very first thing that we could do. Actually, no. Yeah, okay. Yes, let's do that. So maybe the very first thing we would do is let's center the location. So if we were to go into the Google app Maps or Apple Maps, here's both Google Maps. Here's Melbourne. We could zoom in. Where are we? Springvale. This way. Yep, thanks. Clayton. Where's Bunnings? Clayton University campus. There we are, somewhere around here, right? As I'm dragging this around, up in the title bar, you'll see that, and this will be the same in Apple Maps or Google Maps, you'll see this little thing here, which is like -37.90 and 145.133. These are a longitude and latitude. So this is a good way to just roughly get a location. And if I center the map on, I don't know, the campus, we could do this, and we'll take these coordinates And I just want to show you how we could set the map to an initial view. So let's go into here. Let's go into here. We'll rename this as well and call it, come on, map view controller. So in my view did load, I just need something like, well, how we represent a coordinate would be like this. We would say Monash, Clayton, and we use a CL for call location, location coordinate 2D. And that's pretty good, which might be from some previous thing I did, but here you go. Here's a latitude, the one we just pasted from Google Maps, and a longitude, right? So that gives us a location. That's basically a coordinate in 2D space, got a latitude and a longitude. CL is for core location. Core location is another framework. It's the lower level one. It's included by MapKit, which is why it's not complaining about it. Yeah, if we wanted to create an annotation, that's what we'd be doing. We don't want to do that. If we want to set a region of the map view, we need what's called a MapKit coordinate region. So we could say let Monash region equals MapKit coordinate region. And for a coordinate region, you have a couple of things. You can give it a rectangle. That's not what we have. You can give it a center and a span. Or you can give it like latitudinal and longitudinal meters if you want to get like a rough square for something. So we're going to use this one. For our center, we give it what we just had before, Monash Clayton. Then we can say how much of the map do we want to display. So maybe we just want to display a kilometer in each direction. So we can just say 1,000 meters, right? So that gives us a region. Now we can tell the map view, center my map on this region. So we can say map view, set region, and you give it a region and tell it whether it's animated, because you can do this over time. So we can say Monash region and we can just say false, right? So if we do this, it should load our map centered on the Clayton campus with, a kilometer of visibility. So there we go. That's worked. There are different types of maps that we have access to. So, the very simplest version of or thing we might want to do is we can just say map view, and we can give it a preferred map view, dot preferred configuration, and we can say MK like hybrid map configuration, or the satellite one is it called satellite standard, or it's called imagery, I think, imagery map configuration. So this one is like satellite images. So if we run this, we see satellite images. And then there's a hybrid one, which is like satellite images, but it shows road names. And I think it may even show building information on there, which I guess I could show you as well, which is the MK hybrid one. Right. You see the important fast food joint at the campus center. And yeah, we see things like Wellington Road and other labels like this. So some other things that you might be interested in. This doesn't work on all of the maps, but you can do it for the standard configuration, is you can get traffic information. So how you would do that is instead we would say let configuration equals MK standard map configuration. And why I'm doing this is because I'm using the default configuration, but then I'm changing a property of it, which is to show traffic. So I think I can just say configuration dot shows traffic equals true. And with any luck, we see this is about like 9:30 in the morning. Expect there might be some traffic.
A little bit.
A little bit, yes. Here you go. So on Princess Highway or Dandenong Road, there's some red bits here. Here's
Monarch inbound is still shit.
Monarch. Thanks, Jason. Yes, Monarch inbound is still not great. Exactly. So you can see traffic information shown on here. So these are some of the like quite powerful things you can do very quickly. I mean, what have I done? Like half a dozen lines of code or a dozen lines of code to get some of this stuff. So I'll leave these examples in here, and yeah, you can sort of play around with these yourselves. This is a bit longer. Well, okay, let's do a couple of things. Let's show the user's location. No, you know what? Even before I show the user's location, I'm going to show you the path planning, like finding directions to something. So finding a route to somewhere. So this is a bit more involved. I'm not going to write this from scratch. I've kind of written it myself earlier, but I'm going to adapt it a little bit for you. Interestingly, okay, so I kind of added this quickly yesterday, and you'll be intrigued to know I didn't know exactly how to use these classes, and I thought, oh, you know what, I'll just ask ChatGPT to do this. It gave me, I could actually put up, maybe I'll put it up on Moodle. It gave me some code that was about 3 times as long as this, and it used completion handlers. And when I asked it to use the async version, it wrote its own wrappers for all of the completion handlers, and it made the code like really complicated. And I went, that can't be right. And I went and looked at the documentation, and sure enough, it's there are async await versions of the methods you need to use here. So I rewrote it myself, and I think it's much simpler and shorter and makes more sense. But I might put up the earlier version so you can compare and just see for yourself. But
Yeah, that's one thing that Apple really does is they usually update their software to clean up and reduce the amount of work you need to do to get things to function. So ChatGPT, I don't know if it's running off old frameworks and things. It just blows it out into stupid proportions.
I don't know. But anyway, so the important thing here is we need to use several calls here that are going to be asynchronous. Okay, so they're potentially going to throw errors, and they're going to need to be, we're going to need to await them because they're going to take some unknown time to finish. A bit like our web services we worked with. So I'm going to put all of this in a method which I'm going to, we haven't done this before, but I'm going to call it, I don't know, draw route. And for draw route, this draw route method, we're actually going to make this an async method, and we're going to mark the method as being able to throw. Okay. Now, what this means is I can put code in here like I could in a task block that awaits, and I can also put code in there that throws and just put a try statement on it. And this method itself will throw. And if I ever call this, I'm going to need to call it in a task block and call it with an error handler. So, I mean, we could do that now. Like it would look like this. Let's say in here, we're just going to create a task block. We're going to try and await my draw route thing. And if there's some kind of error, I'm just going to throw a fatal error. Okay. Um, Now, what does the
Sorry,
code in this
you going to
draw route
Monash?
looks like? So this was my kind of cleaned
Sure.
up way
Thank
of
you.
writing how to do this. And the code is a little long, so stand by, but I'll talk you through it. So, okay. First thing we do is core location provides us something called a geocoder. It's a class that allows you to do either geocoding or reverse geocoding, which allows you to turn a location into a longitude and latitude, or turn a latitude and longitude into an address or a nearby address. So that's what we're doing here. We give the geocoder instance an address string, which, for the purpose of making this work, we really need it to be as specific as possible in case there's a research way in a city in Clayton in the US or something. Sometimes these frameworks get it wrong if there's similar addresses in foreign countries and things. So we be as specific as possible. So I'm doing like the New Horizons building, which is inside the Monash campus, to Huntingdale Station, which is a typical bus route that many of you might take if you were traveling by public transport. This thing, geocode address string, gives us back an array of place marks. So there's a bunch of different little classes you would need to get familiar with. And you can see why ChatGPT might give a weird version with a completion handler. The documentation for this actually says, it you call it with an address, you give it a completion handler, which is some code of yours that gets called when it finishes. The documentation does also have the async await versions, which is what I went and saw, and then I rewrote it myself, because you don't need to use this or wrap this yourself. You can just directly use a version like this that returns the thing, but it is async, so we need to await it, which is what we're doing here. The other thing to be aware of, and this is where we start talking about errors, is if you delve a bit deeper into this code, you can find out, if you go look at the completion handler here, that it throws an error and it'll say error is nil, or an error object indicating the placemark data was not returned. For a list of possible error codes, see CL error code. And it turns out this is an enum that inherits from error. And here are a bunch of different core location errors. We're doing geocoding, so let's just pay attention and say, here are some of the things that can go wrong. We're in the middle and we cancel a request. There's no result found, or a partial result is found, which basically means I think it's unsure of whether or not it was able to return this location. So here's the things that can go wrong. We're going to kind of pay attention to this geocode not found result, because when I do the error checking thing, I'm going to update to use that. Let me talk you through the rest of the code here. We get place marks for each of these, which a place mark, it could go wrong. There might be none. So we're just going to check that we have a start address and an end address that were able to be geocoded. In order to do directions, you use something called MK directions. You make a request and you need to set a source and a destination. But these source and destinations are an MK map item. And an MK map item you can create from a place mark. And oh yeah, and the thing to realize is, even though we had a place mark here in this geocode address string, these place marks were core location place marks. So they're at a lower level, and we need a map kit place mark. So that's why we use the map kit place mark, and we give its constructor the core location place mark. So we get a higher level version, the same thing. And we've seen this before in the sense of colors. I think we used core image level colors to get the components of a color. And we've also used UI color, which is a higher level user interface color class. Anyway, we create these two items, we create a request, and we tell it, is this walking directions? Is it automobile directions? So you can say transit or walking or automobile. So we'll say automobile. It's very old fashioned, automobile. We then construct our directions from this request, and we ask it to do the calculation. And again, this is another place where I don't know if it needs a web connection for this. Maybe it does, maybe it's done locally, but you need to await it because it takes some unknown amount of time. And we check that it has an actual route. And one thing to be aware of is it can calculate multiple routes, and you can ask it for that here. So, it could say, oh, there's these 3 different routes. They have different time, they have different distance. You could show them to the user. I'm just going to get one. So I'm only going to check the first one in this array. Then I'm just going to clear previous overlays. I'm going to add an annotation for the starting point and an annotation for the end. This was another place that ChatGPT wrote some really crazy code to get the coordinate, but the place mark has the coordinate, so it went about it in a super strange way. We add these annotations to the map, and we add an overlay. Then finally, you don't have to do this bit. If we just added the overlay, it would be displayed on the map, but we have to find it. But we can also make sure that route is visible, and we could do that again via this set region, but there's also this set visible map rect where you can give it a rectangle and it can make sure it's displayed within the map view. And we do that by giving it the bounding rectangle of the polyline, which is the route, and we give it some edge insets. Now, you could run this. And you could find, you see the 2 pins, and after a couple of seconds, it sets the visible map region, but we don't see any route. Okay. This is another thing that ChatGPT didn't do, right? It turns out when you want to display a polyline, you have to actually describe to map view, how it gets rendered. Okay, so there's a delegate method of the map view, and we can put that down here. So it's called map view render for overlay, and it returns an overlay renderer. And by default, it just uses this overlay renderer, but I think it renders these things with like a width of maybe 0 or just invisible. We can say we want 5 points for the line. We want it to be in blue, and we want an alpha level, could be 0.7, so it's semi-transparent. And if we do this, then you'll actually get a blue line displayed on here, and you'll see the most preferred route that is required to get between these points. Any questions from anyone, by the way? People just happily watching along.
Yeah, hang on, here we go. So okay, so
Someone said something funny.
yeah, there is one comment here. It's like, how do you expect us to describe what we've learned when this topic is the same as learning French, advanced French for beginners? It's a good question, I guess. Sort of in
It's
terms
the
of,
same as learning French. Why is it the same as learning French?
yeah, I'm sort of curious.
If whoever gave that question, I'd be interested to hear clarification of why you say it's like learning French. I mean, look, in some sense, you're right. Learning a programming language and the frameworks associated with that programming language are learning a new language, right? So,
Well, yeah.
like, there are certain conventions that we see here, and while I wasn't familiar with these frameworks, I can go and look at them. I understand what a completion handler is. I understand what async await is. I understand what some of the individual classes are and how they fit together. And I have to go and read the documentation to do this. Or I use internet sites that suggest how different components fit together. And then I need to go and study it and learn my understanding. It's the same way you would in revising your understanding of a language, right? You learn the core components of that language about syntax and certain things, and you refine it over time, and you do it through practice, right? So a lot of stuff we give you in the unit is around how to understand the basics and then what you need to support your next level understanding. But you have to practice it. Like anything, you can't expect to just be good at this stuff. You need to keep trying it and learn from your mistakes, play around with things. It'll take time. I wanted to talk about the error handling here. At the moment, we do some pretty bad error handling. We just do these like fatal errors all over the place. What you probably want to do is show like an alert view and this, right, rather than a fatal error, you might want to show something like this. You give an alert controller and you show an error message. Oops. And this could say unknown error. It could say location unknown. Right. Let me just copy this out of here and put in something random here. And we can see if we can make this misbehave. Okay, we get unknown error, right? I could put something more useful in here. I could say unknown error, and I could actually print the error message. Right? And then I get something that is equally impenetrable. It says error, CL error domain. It's basically saying it's a core location error, and it has an error code, right? This is not terribly useful to us. This is where the documentation we just looked at for the core location can be useful to us. So we saw there was this geocode found no result, which is part of this thing called a CL error. You can actually catch individual errors. So we haven't seen this before, but how you would do this is in here. This is a catch-all kind of error. Where it will catch any error at all, but you can be specific in handling errors. And if you want to be specific in handling errors, how you do it is you list the error here, CL error, and you give geocode found no result, and you are actually handling this particular error here. So we can give an error that is more useful. We can say, address can't be decoded or geocoded. And then you'll find instead of that impenetrable alert, we can see something meaningful to the user. So you can have, multiple of these catch statements, and the last one is sort of their patterns that get caught, and the last one is a catch-all one that shows everything else. So we could, if we wanted to, handle those fatal errors that we had by cleaning this up a little more. We could create our own enum that said like unable to geocode address or unable to get route or something like this. And you'll see this one I also haven't shown before is a custom error we've got, but it has arguments. So this is something that you could access and display in your error message if you wanted to. So how you could, we saw how to create our own errors, but we didn't see this one before where we could provide additional parameters to them. And how you would use this is I could find some code like maybe here where I've got a fatal error message. Instead, I could say something like throw, what did I call it? Root error? I can't remember what I called it. Draw error. Draw error. What a stupid name. Root error. I'll call it root error. And here I can say root error dot unable to geocode. And I'm just going to say start address and end address for each of these. But the point is now this method just throws these and I could display them. And for this one down here, I could also say throw and give a root error dot unable to get root if we can't figure out a root for these. And then if you wanted to, you could like handle each of these individually with multiple catch blocks. So you could have one that is handling this, what I'm now calling root error, right? And it gets access to this address, and then it's something that you can use inside the catch block. So this is a way that you can, I guess, be smarter about handling errors and showing more meaningful things to the user and doing it in a way that, you know, they can actually see a message on the screen and understand what's going on here. All right, so we're pretty much at the end of the time now. The only other thing I might have shown you is just tracking the user's active location. I might do a quick follow-up video for that online, and I'll put all this code up on Moodle. If you do have any questions, we can answer them for a minute or two, and then otherwise you can answer them in the forums, and we'll see you in your lab classes. And I should say our lab class is from next. So this week you'll do the last of your labs, week 6.
Marked for the last marking.
Yeah.
But the labs from next week onwards are not marked. So for week 8, 9, 10,
Right.
11, 12, you'll be actually getting marked based on your progress.
Correct. So lab 6 you're doing this week is still assessed next week. And then from week 8 onwards, is that right? Yeah. From week 8 lab classes onwards, we start to do check-ins and we assess 4 of the 5 remaining weeks as progress on your final app. But you can still work on the supplementaries. All right. Thanks, everybody. Yeah. Okay. Thanks, folks.